Good morning, everyone. Welcome you all to this one-day online faculty development program on networking simulation using NetSim software. I am Shravan Kumar from Delsoft Technologies Private Limited, New Delhi. And Delsoft, established in 2004, is a research-based company engaged in promoting path-breaking software solutions primarily for the education sector, thereby helping the institutes to enhance their infrastructure and provide best possible software solutions. So we try to conduct these kind of online sessions to aware faculties and researchers about latest technologies and related software to them. In continuation of this, we have organized today's session. Today, we cover some core areas of research in networking like MANET, Mobile Ad-Hoc Network, Wireless Sensor Network, and IoT Internet of Things by designing and implementing scenarios related to these technologies. Today's session will be in two parts. In first part, we cover Internetworks and MANET scenario with some common attack problems like Sinkhole attack in MANET and its intrusion detection system following the introduction of NetSim software. Then after a break of 15 minutes, we will cover WSN and IoT technologies with implementation of LEACH protocol in WSN. We'll keep your mics on muted mode just to avoid sound interference. During the session, anytime or end of the session, you can write your question in the chat box given in the panel. And after the session, we'll try to answer all your questions one by one. So once again, welcome you all for this one-day FDP on networking simulation using NetSim software. We believe that session would be informative. After this session, please don't forget to send us your feedback and suggestions by email so that we can work upon them and improve it better. So let's start our presentation. So here is NetSim 9.1 version software for simulation and emulation of various network technologies in a single window solution. So first question here is why we require NetSim or any other network simulator. So here we can see there are some observations given here in networking domain where we can see that our existing network traffic will be 4 times this year as per our use of mobiles, tablets and other handheld devices. As you are aware of today's scenario where many mobile companies and network operators are making internet as convenient as possible to the people by giving lucrative offers. So in result of this, more and more devices are increasing in the existing network traffic. In today's scenario, we watch 2+ billion videos every day. We surf the internet daily. We use social media. We watch live TVs these days. So these all constitutes heavy traffic on our network. So on having these observations, it leads researchers in this field to conduct research on these domains provided here like mobile ad hoc network, wireless sensor network, cognitive radio, LTE, LTE advanced, and IoT Internet of Things. And as many mathematical calculation is involved with these researchers, so it is very cumbersome to conduct this research manually. So simulator reduces this effort and makes our work easier and accurate. 50% of all research papers in IEEE and ACM, that's why I refer a network simulator to be used in this research. Now overview. NetSim is a scientific tool for designing and validating networks and protocols, and hence it has a lot of relevance in protocol research and development. It has a wide range of network technologies which is possible to simulate here in NetSim are Internetworks having LAN, WAN, wireless LAN, mobile ad hoc network, MANET, WiMAX, cellular network which consists of GSM and CDMA, cognitive radio, LTE and wireless sensor network which includes Zigbee also, and then IoT is also added. In standard version of NetSim, users are provided with C source code of network protocols which are implemented based on IEEE and IETF standards. The purpose of giving the source code here is to enable users to edit the standard protocol code according to their own implementation, and further they can link it with NetSim and analyze the performance of the newly designed protocol. Now, NetSim customer segments. NetSim has a huge number of customers varying from industries where it is used for network design and validation to defense labs where it is used for network-centric warfare simulation. It is also used in R&D labs for protocol development and new technology testing. Many PhD research papers are published by utilizing this tool. NetSim also has an academic version which can be used in network labs of undergraduate curriculum and advanced network labs of graduate courses in electronics, computer science, and other related domains. Now, architecture. This is the internal architecture of NetSim, which provide you a holistic view of NetSim, where users will design the network and configure it in a GUI interface, which will be simulated by NetSim engine and thereby provide multiple metrics regarding performance of the simulated network provided there. Here, user is not required to write any script or code while designing and configuring the network scenario. One of the striking features of NetSim here is the NetSim engine itself. As you can see, it is utilizing a virtual network stack which actually mimics the real-world TCP/IP stack and hence makes it very easy for any user to edit protocols and also get fairly accurate results. Furthermore, user can also perform research on cross-layer protocols like LEACH in WSN. Now, NetSim technology matrix. NetSim is divided into modules or components. So this is a list of contents of each component and the corresponding IEEE and IETF standards referred during implementation. For illustration, component 1 consists of protocols implemented in WAN, LAN, and wireless LAN like Ethernet, IEEE at 802.11, AB, GN, AC, and P. Component 1 is the base component, that is all other components require component 1 to run. Similarly, component 2 consists of network based on legacy technologies, component 3 consists of BGP network, and component 4 contains mobile ad-hoc network and WiMAX technologies. Cellular technologies like GSM and CDMA are present in component 5. In the same way, component 6 contains wireless sensor network, IOT, and personal area network. Component 7 contains cognitive radio network, and 8 contains LTE and LTE advanced network implemented according to 3GPP standards. Now, modeling and simulation. So first we have scenario creation. Here, user can easily click and drop devices and configure them in GUI. They can also model multiple traffic of various types like FTP, HTTP, custom, etc. among these nodes without even writing a single line of code or script. User system having less memory may face issues while creating large network scenario in GUI, like let's say 1500 plus nodes and 300 plus routers. For this purpose, we allow the user to write the scenario in an XML file. This is suggested only for advanced users, and NetSim support team usually assists the users while writing such a scenario. For further assistance, automatic format verification will indicate if the user is writing anything wrong or not in the XML file. Now, metrics and animator. NetSim provides distinctive quantitative metrics at various abstraction levels, such as network metrics, application metrics, link metrics, protocol metrics, and device metrics. At the end of simulation, and with the help of metrics, user can analyze the behavior of the modeled network and can compare the impact of different algorithms on end-to-end behavior. So the first network metrics allows users to view the values of the metrics obtained based on overall network. An application matrix displays the various metrics based on the application running in the network scenario, like throughput, delay, and many more. The link matrix displays the value of the metrics related to each link, like packet transmitted, packet errored and collided, etc. Protocol metrics here displays the protocol-based metrics which are implemented in the network scenario. Metrics will vary depending upon the type of network simulated. In device metrics, it displays the value of queue metrics for the device containing buffer queue and access points. Now, packet animation enables user to watch traffic flow through the network for in-depth visualization and analysis. Unlike other network simulator, which only shows the transmission of packet, NetSim goes a step further and displays some basic packet information like packet ID, type of packet, and whether it is successfully transmitted or not. User can also observe the changing location of nodes due to inherent mobility. Now, packet and event trace. NetSim allows user to generate trace files which provide detailed packet information useful for performance validation, statistical analysis, and custom code debugging. So packet trace logs a set of chosen parameter for every packet as it flows through the network, such as arrival times, queuing times, departure times, payload, overhead, etc. NetSim is a discrete event simulator, so the event trace records every single event along with associated information such as timestamp, event ID, event type, and more in a text file or .csv file. Now, dynamic metrics. Dynamic metrics allows user to monitor the value of a parameter over simulation time. This is essential for researcher to understand the behavior of a network at any instant of time. So here link throughput, application throughput, and TCP congestion graph can be dynamically plotted. These plots can be done offline or during the simulation. Now, writing custom code in NetSim. So on this slide, we have tried to answer the question asked by many people. Usually in a presentation, that how this software is different from the open source software available freely on internet like NS2, NS3. So as we know, we have to write a lot of programming while using any open source tool for creating and simulating any network design. So in the graphical representation, you can see users usually spend 80% of their time understanding the simulator and its language, rather focusing on the user algorithm, and sometimes people fight with its installation procedure that creates hassle using it. So considering these difficulties, NetSim has been designed with its GUI feature along with custom code editing, where we can design and analyze our network in GUI, and if we wish to change anything in existing protocol or wish to create new protocol, that can be done using Microsoft Visual Studio 2010, where we can save our files in DLL extension and link it with NetSim GUI. Now NetSim has interface with some of the third-party tools. which can be interfaced with NetSim. So first is Wireshark interfacing. Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analysis, and communication protocol development. In NetSim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packets and transmit it within the simulated network. Hence, Wireshark can be used inside NetSim to capture these packets at multiple node location and perform further analysis. Now, NetSim interface with MATLAB. NetSim also has an interface with MATLAB software where you can use functions given in it related to network technologies. By calling those functions in programming using Visual Studio, so when we save those DLL and link it with NetSim, we can use MATLAB functionalities. Now NetSim interfacing with Sumo. This is another interface that NetSim has called Sumo, that is simulation of urban mobility. It's a free and open source tool for vehicular simulation which has further developed and edited with the help of APIs provided to interface with NetSim. These are research and development done using Sumo like traffic surveillance, autonomous route choice, eco-aware routing, etc. Now for interfacing Sumo with NetSim, we need a Sumo configuration file which has some subfiles inside it, that is edge file, node file, network file, and vehicular routes having various information. With this mobility file, we interface Sumo with NetSim, which further simulates the network scenario of MANET and generate output parameters such as performance metrics, packet animation, packet trace, etc. In order to reduce time and effort of protocol developers, NetSim provides APIs which can be reused to perform activities like packet creation, deletion, IP address comparison, and many more. NetSim also provides a manual in the help section to assist developers while writing or editing the source code. Now, before going to the wireless communication and MANET part, I'll take you through NetSim software and see how we can work on it by designing a simple scenario of Internetworks. And also we'll see a custom code environment of Microsoft Visual Studio 2010 in C language for editing any existing protocol. So this is the environment of the software when you first open this. And for creating any network design, you have to go for simulation. In simulation, new, you will find all the components which are existing in the NetSim will be here, and you have to choose any of the component to design the network related to that component. So we have to design first Internetworks. So after choosing the Internetworks, you will find the environment of the software where you have to drag and drop the devices and click here in the environment to drop the device, and you can use the link, either it can be wired or wireless related to devices. You can join the network and configure it. So here you can see some of the devices available here. So some nodes are enabled and some are disabled. So disabled nodes are related to different technologies. So these are disabled here. In the nodes also you can see wired node and wireless node is there. Other nodes are disabled as they are related to different technologies. So here we are having wired node. So we choose some wired node and place it here in the environment. Let's take some more nodes. Now we can connect it through the wired link we have. Now we have connected these nodes and created a wired link. Now if you want to connect a wireless network through this network, we can connect an access point to the router and connect it through a wired link. Now through access point, some wireless node can be added and it can be connected through a wireless link. Okay. Now we have designed our network, which is a combination of wired and wireless. Now we can see the properties of our nodes. So first click on the wired node A and you will find the property of the node. So first property you'll find is global properties. So in global properties you will have device name, device type, okay, then a type of the node, then location of the node, XYZ coordinates, then we'll have a Wireshark. So as I've shown you in the presentation that we can enable the Wireshark on any node and it will capture the real-time packets during the simulation. So if you make it online, the Wireshark would be enabled at the time of simulation and it will capture the packets. So I'm making Wireshark enabled on first node, wire node A, and we'll see how it will work. Then application layer is defined outside. This is for application. You have to drag and drop and define the application layer. So transport layer, we have TCP and UDP protocol. In TCP, we have protocol MSS, congestion control algorithm, 4 types of algorithm. Then window size we have, then acknowledgement type. So different other parameters are also there. So these parameters which are defined in the properties, we can understand these parameters if we require by using this information tabs we have along with the parameters. So let's say we want to see about the MSS. So MSS, if you click in the I tab, it will give you the definition of MSS. It will give you the formula how it can define, and it will give you the range in which you can give the values to MSS. Likewise, you can choose any of the parameter. It will give you the information regarding this. This is for the information of these parameters. In network layer, we have IPv4. And in interface of Ethernet, we have network layer, data link layer, and physical layer. So data link layer and physical layer are by default given the values. And in network layer, we have to define the IP address, subnet mask, default gateway, ARP retry interval, try limit. Okay. So by default, we have given some parameters in which the simulation will run. If you require, you can change the parameters. So we'll just accept it for default and we go for switch properties. So first global property is common for all the nodes. Is device name, device type, coordinates. Okay. Then we can see the 3 interfaces here. So as this switch is connected to 3 nodes, 2 wired node and 1 router. So it has 3 interfaces. So in first interface you will find is for wired node A. In this you will have the data link layer parameters having MAC address, buffer size, switching latency, switch priority, switch ID, spanning tree, switching mode. Either it can be store and forward, cut through, fragment free, and Ethernet standard, speed, STP cost. So all these parameters which are variable we can define, we can change according to our requirement. Likewise, we can change the parameter for other 2 interfaces, interface 2 for wired node B, and interface 3 for router G. Then we accept and see the parameter for router. So global property is common. Wireshark is also there. You can enable Wireshark on router also. Then in transport layer, TCP and UDP is there. Network layer, IPv4 is there. apart from IPv4, we have a firewall status given here. So you can enable the firewall on any of the node, and the router will not send any packet. It will block that node. It will not send any packet if you configure the IP address of that device in the firewall. We have to make it true to enable the firewall. The firewall feature is there in router. So it is also connected to 3 devices, 2 switch and 1 access point. So it is also having the 3 interfaces. So in network layer, you can define the IP address, subnet mask, scheduling type, buffer, okay, and detailing the physical layer are common. Likewise, we have other 2 interfaces. So we just accept it and see the properties of access point. In access point, the global properties are common. Varsha can be enabled, and we have interface of wireless, where data link layer, physical layer parameters are there. Okay, so you can enable the IEEE 802.11e rate adaptation algorithm. You can define. This is the minstrel and generic algorithm. Minstrel is a newly added protocol rate adaptation algorithm that can be used for the wireless communication. Then MAC address, basis type, try limit, RTS threshold, buffer size. Okay. Then in physical layer, you can define the standards of wireless IEEE 802.11 APG and ACP. All these are there. Transmitting type, transmitting power, frequency band, CCA mode, okay, PD threshold, standard channels. All these are for wireless parameters. And Ethernet interface is made default. So we can accept and see the wireless node properties. So global property is common. Transport layer we have same TCP UDP. Network layer we have IPv4. Interface wireless, again we have the wireless parameters. Okay, data link layer also. Then we have physical layer. Again all these standards. Okay. So we can accept it. Now we have configured our network. Now we'll drop down this application tab, and we can send an application over this network. So in properties of application, you can see various application type that we can send in the network are CBR, custom, email, HTTP, video, voice, database, FTP, peer-to-peer. Okay, so let's say we are sending a CBR packet from source ID 1 to destination 9, from 1 to 9. Then we have packet size. We can define the arrival of the packet size, distribution of the packet size. Okay. Then we can have the value of the packet. Then we can define the arrival of the packet in interval timing. We can set the distribution and value of the timing microseconds. So apart from this application, we can add some more application. So if we click on add, one more application is added, application 2. Here, let's say we are defining the custom application from let's say node 2 to node 5. Node 2 to node 5. Other values are common. Or we can change the packet size to exponential, or inter-arrival timing to exponential. Okay, so we can accept. You can see a line is there where CBR packet is sent over 1 to 9, and custom application is sent over 2 to 5. Okay, so now we have configured our network and we have defined the applications. We can go for simulation, and before the simulation we can add some more analysis here. which we have seen in the presentation: packet trace, event trace, and dynamic matrix. So it is very easy to configure these analysis. We just have to click on packet trace, and we will have the attributes for packet trace, all the attributes: segment ID, packet type, control type packet, source ID, destination ID, transmitter ID, receiver ID. All these attributes are there. You have to just click on OK, and all these attributes will be shown in an Excel format after the simulation. Same as in event trace, we have the attributes for events. Okay, fast Ethernet, RIP, TCP, IEEE, OSPF. So all are there. So click on OK. Dynamic metrics also, you have to give in the throughput for links, all the links, and application metrics, congestion window metrics. Or we have to choose plot graph after simulation, because in second option, plot graph during simulation, simulation will slow down significantly. So we choose plot graph after simulation. So click on OK, and now you can run your simulation. Here also you can define your timing of simulation. So we provided 100 seconds. So we can record our animation. We can play and record both at the same time. And we don't play and record animation. We can only see the result. Three options are there for animation. So we record our animation to see. So as we have enabled the Wireshark on node 1, Wireshark is started. Along with the simulation, you can see the packet are being captured. So these are the timestamp, source, destination. These are the protocols, length of packet, and information regarding the packets. So it is the real-time packet capturing of Wireshark in any network. So we minimize it and see after this. Our simulation is also over. So here we can see the performance metrics after the simulation. So first we'll get is network metrics, where we'll have a simulation timing, packet transmitted, packet errored, packets collided, bytes transmitted, payload transmitted, and overhead transmitted. So definition of these matrices can also be seen. When you click on this, you will get overhead transmitted definition, packet transmitted, bytes transmitted. This for study purpose, if you want to have the detailed information. Then we'll have link metrics, queue metrics, TCP metrics, IP metrics, OSPF, IEEE 802.11 for wireless, ARP metrics, application metrics. Then we have link throughput, application throughput. This is for dynamic metrics we have. Then we have the packet animation, and we have packet trace and event trace also. So in link metrics, we can see each and every link information. Link IDs are there. We have packet transmitted, errored packets, collided packets. Then we have byte transmitted, payload transmitted, and overhead transmitted. Then in application metrics, we can see the application we have added. It is CBR and custom from 1 to 9 and 2 to 5. These are the packet transmitted and received. We have the throughput. We can add this throughput to get the overall network throughput. Then we have 802.11 metrics for wireless, having frame sent, frame received, RTS and RCTS sent received. Okay. Then we have added the link throughput. In dynamic metrics, we have added link throughput, so we can have the graph of link throughput of each and every link. Link 1, link 2, link 3, 4, 5, 6, and 7, and 8 for wireless. So this is time versus throughput graph we can have. Then we can have the application throughput graph. So we added two applications. One is for CBR and second is for custom. Then we can have a graph for TCP congestion window also for 129 and 225. Then we can have the packet animation where we can see our packets moving from one node to another. So we have added 129 and 225. So as soon as it gets the acknowledgement, we'll start sending the packet. You can see custom application is being sent from 225 as it gets the acknowledgement. Now it will send the signal, and as soon as it gets the acknowledgement, node 1 starts sending the CBR application. You can see CBR application is being sent. These signals which are being sent can be seen here in the log of the text available here, where we have the source name, destination name, packet info, status, and simulation timing. So from which source to destination the packet is sent, packet info, which packet is there, and either it is successfully sent or not. If it is error, it will show you error. And this is simulation timing running. Okay. So we'll send the packet. You can increase the animation speed to get the animation faster, or you can slow it down to see the animation slower. This is your simulation timing running here. You can play and pause. You can stop here. So you can stop here and see some more analysis. We have added packet trace and event trace. So just click on the packet trace and you'll open packet trace in Excel format. So here each and every packet information is given here. So whatever attributes we have added, packet ID, segment ID, packet type, control packet type, source ID, destination ID, transmitter, receiver, and the values of the packets. All these are available in the packet trace. So this is for research. So let's use the some functionality of Excel and see how we can use it. So here you can see around 5,000 packets are there, and each and every packet information you can see. So if you want to have the packet 1, you can see packet ID 1. Okay. Which application is being sent, which node to which node, source and destination, transmitter, receiver. Okay. All this information regarding the packet 1 is there. Likewise, you can add some more packets. You'll get the information. This packet 1, 2, 3. If you want to add some more packet from 5032 packet, we'll get the information accordingly. This is how we can analyze the packet trace. Likewise, we have event trace. So event trace, each and every event information is there. These are the event ID which has been performed in the network. You can have the event type, event timing, device type, device ID. All the information regarding the event is there. You can filter it out, which event ID you want. Okay. Apart from this, if you save this experiment, there is a tool called NetSim Analytics. If you click here, you will get a tool called NetSim Analytics. Here, as we know, metrics is created for every network we design. So metrics file contains the result of the network we design. So we compare different metrics file here by browsing those files. Let's say we are having the Internetworks scenario. We have a metrics.txt file we open. We have designed some of the Internetworks scenario having different parameters here, and we are choosing the metrics file for those scenarios. So I've chosen 4 metrics of Internetworks having different parameters, and we can analyze those metrics file over these parameters like simulation timing, packet transmitted, packet errored, packets collided, bytes transmitted, and payload transmitted, and overhead transmitted. Okay. So we can compare different metrics file here in NetSim Analytics. So this is how we can design and analyze the network. We configure it and we analyze through the NetSim GUI. And we have also added Wireshark interface. So here we can see these packets has been captured. So there are some tools of Wireshark also that we can use to get some graph like time sequence, TCP trace, round trip time graph, throughput graph, time sequence T1 graph, and window scaling graph. So these are the features of Wireshark that we can use for some more analysis. IO graph we have. Okay. So this Wireshark functionality we can use. So till now we have seen the GUI functionality of NetSim, where we can design and analyze our network. Now, when you want to create a new protocol or you want to edit any existing protocol, so for this we have to go for the Visual Studio environment for creating or editing any protocol. So let's go to the installation directory of NetSim, which is C program files and NetSim standard. So here we are having some folders. So in bin folders, you can see all the protocols available in NetSim are listed here, having the DLL extension. So the NetSim understand the DLL extension of these protocols. So any protocol you create, a new protocol, or you have edited any protocol, that has to be saved in the DLL extension, and that edited DLL has to be placed here in the bin folder. So through this bin folder, the NetSim GUI accesses the protocols edited or created protocols. So for editing any protocol, you have to go for the SRC. We have created a copy of the simulation folder just to retrieve our original DLLs. So you have to open this netsim.sln file. This is netsim.solution file. When you double click here, the Visual Studio environment will open. and you will get the codes for the protocols available. So all the protocols listed in the NetSim are here. Here we have edited a DSR protocol. So we have opened the dsr.c file and we are having the codes for dsr.c. And for demonstration purpose, we have just edited the init function of NetSim DSR for printing a hello world. We have given the command. So if we save this DLL of the DSR and access the DSR file through the NetSim GUI, it first should print hello world in the command prompt, and then we put any key and it will simulate our network further. So let's see how it can be implemented. So for printing the hello world, this is the demonstration purpose for showing you how we can edit anything into the protocol. So we have edited for printing the hello world. Now for building the DLL, we have to build or rebuild the function. So when you build it, it will give you a DLL file in the DLL folder of this simulation file, and you will get libdsr.dll. So you have to copy this edited DLL, libdsr.dll, and paste it into the bin folder of NetSim. So here we can see libdsr.dll is already available here, which is our original DLL. So when you copy this, you can replace it, but we have to retrieve our original DLL also for using the default values of DSR. So we just rename it to some, let's say libdsr original to retrieve our original DLL. And now we can copy our edited DLL here. Now this libdsr is the edited DLL and this is our original DLL. Now if we access the DSR protocol in any scenario, our edited DLL should work. Now we'll go to the NetSim GUI and see how we can access our DLL file. I'm opening a MANET scenario where we have used a DSR function, DSR protocol. So we can open the properties of wireless node, and we just have to check in network layer, routing protocol DSR should be selected. So by default it's selected. So accept it, and you can run your simulation. So we'll see the details of these nodes and function of MANET in further. So we'll just run it to see our edited DLL is working or not. So we'll run our simulation. And we can see in the command prompt that hello world is printed first before running the simulation. So we can see our edited DLL is working. So if we click here, it also shows you that detected a change in libdsr.dll. So press any key to continue. So if you press any key, it will continue the simulation further. So now the performance metrics will be there after simulation. This we'll see after this in detail. So this is just to show you how we can change anything into the protocol, because we are going to use this in our further presentation in MANET and WSN, how to edit these protocols. So I'll just show you to see this. Now let's go to our presentation again to see the MANET functionality and wireless network. Now wireless network can be of two types. First is infrastructure-based network, which consists of our traditional cellular system having base station infrastructure and wireless LAN using infrared or radio links. So these are very flexible within the reception area, they have low bandwidth compared to wired networks. Then second is ad hoc network, which are very useful when infrastructure is not available. It has only the wireless devices which communicate among them by using set of protocols like DSR and AODV. It can be used for the outdoor scenarios where infrastructure is readily not available, like warfare scenarios, rescue operations, environment monitoring, etc. Now this is a pictorial view of comparing infrastructure and ad hoc network, where in infrastructure network we can see the devices communicate among them using access point connected through wired LAN. Whereas in ad hoc network, devices communicate among them using a set of protocols like DSR, AODV, OLSR, and ZRP. Now, why ad hoc network? So, as we know, in infrastructure network, we require a set of devices for communication in a certain range, which is not possible to deploy in various difficult situations like military operations, disaster areas, forest areas, etc. So then we prefer ad hoc network over infrastructure, where we only require wireless devices to communicate. It is also easily deployable and useful in such areas where infrastructure is not available. These are the various applications provided here which can be used in MANET, like battlefield communication, disaster relief management in rescue operations, multi-person gaming, and personal area network, etc. Now, challenges in mobile environment. The wireless communication has various advantages. It has some challenges also, which has to be overcome to make our system more efficient. There are three types of limitation. First is limitation due to wireless communication, and second is limitation due to mobility. Third is limitation due to hardware device. So as we know, in wireless communication, devices are mobile in nature, means they move in the environment according to velocity provided to them. So in moving, their connection may be lost, and as it is broadcasting communication, data may also be lost. Now, as hardware depend upon the batteries for power, that is also a major challenge to save as much power to them so that they can remain in the network. So these challenging areas are the beginning of research for the researchers to make the system as efficient as possible. Now, before moving on to attacks in MANET, we go to software and see how we can design and analyze a MANET scenario. For designing a MANET scenario, you have to go for advanced wireless network, then in MANET, mobile ad hoc network. Click here, you will get the environment. So in wireless MANET network, we only require the wireless device. So all other devices are disabled here. So we can place some wireless node where we have placed 6 nodes. You can see the properties of the nodes. So global property is common as other nodes. Wireshark is also there. Apart from the other nodes, other parameters, we have the mobility model. As it is a wireless device, so we have mobility model. So it can be 4 types: random walk, random waypoint, group mobility, file-based mobility. So as you select, you will get the velocity. As I selected random walk, so by default 10 meter per second velocity is given there. So let's select it for random walk. Application layer is defined outside. Transport layer by default UDP protocol is defined. Then in network layer, we have routing protocol and acknowledgement type. So in routing protocol, DSR is there, and AODV, ZRP, and OLSR. Acknowledgement type can be of link layer and network layer acknowledgement. Then interface layer of wireless, we have network layer, data link layer, and physical layer. So in network layer, we have IP addresses and subnet mask. Then in data link layer, we can enable the 802.11e and data adaptation algorithm. Then in physical layer, we can define the standards of wireless. Then CCA mode, AD threshold, standard channels. Power we can define either it can be mainline or it can be battery operated. So if it is battery operated, you have to take care of the energy. So energy harvesting can be put as on to save the energy. Then recharging current is there, initial energy, transmitting current, idle mode current, and various other parameters to define for the battery operation. Okay. So accept it. Choose the same parameter for all the nodes. So define the mobility model for random walk and velocity of 10 meter per second. Okay, so define the nodes. Now we can put the application tab and send one application over the network. Let's say a custom application is being sent from node 1 to node 6. Packet size arrival time is taken as default. So now you can see custom application is being sent from 1 to 6. Now we can run our simulation. Here you will get the performance metrics, having network metrics, link. So some common matrices are there which are available with all the network, and some are matrices which are technology specific. Like we are using the DSR protocol here, and we have used the UDP. So this is UDP matrix, DSR matrix. This is for wireless 802.11 and application metrics. So in application metrics, you will get the overall throughput, packet transmitted, received of the destination. Then in DSR metrics, we can have the route request and route reply sent. As we know that in the DSR, first route request is sent over the network, and as it will get the route reply from the destination, it will send the path of the route, get the path information, then it will start sending the packet. So route request and route reply sent is given here, and packet transmitted and received is also there. You can also see the packet animation. So you can see route request is sent. So as soon as it gets the route reply, it will start sending the packet. So as it is a mobile ad-hoc network, so all these devices in between these source and destination will help in communicating between the source and the destination. So either it can find the path directly from 1 to 6, or it can acquire any other path. As it is, you can see it is having the path 1, 4, and 6. So this node 4 is helping the communication in between from 1 to 6. So data is being transferred from 1 to 4 and 4 to 6. This is the packet information. even just below this. Now this is the normal scenario where we are using these devices and applying the DSR protocol, and it is communicating, and nodes in between them are helping them out to communicate between the source and destination. But what happens when this normal scenario is not there and these nodes doesn't support the source and destination and doesn't forward the packet further? So then the that attack problem is exists there. That is the sinkhole attack, when the nodes in between them doesn't support and doesn't forward the packets and act as a malicious node. So let's see in our presentation how the sinkhole attack works. So, as you know, it is a very severe attack in mobile ad hoc network in which a malicious node creates a wrong route to pretend itself to be a destination node and receives the whole traffic without further transferring to the actual destination node. So, after receiving the whole traffic or data, there is a threat of modifying or vanishing the whole information available in data traffic. So, it mainly affects the performance of DSR protocol. In DSR, source sends the route request or RREQ packet before sending the whole traffic. So on receiving this route request, it sends the route reply or RREP packet to the source to send the route information and then sending the traffic. But it is possible to send route reply by some other intermediate nodes if they have route information. So the malicious node take this benefit and send route reply to create a non-existing or fake route. So source node send route request to this malicious node and receive route reply from it. Then source find it most appropriate path to send all the information to this malicious node, which pretend itself to the actual destination node. So all the traffic now goes to the malicious node and it can further modify the packet information or completely vanish it from the network. Now here we can understand the sinkhole attack through this scenario where node 1 is the source, node 6 is the destination, and node 2 is the malicious node. Node 2, the red one, is the malicious node. Now node 1 is the sending traffic to node 6, so our actual destination is node 6. But node 2 sent false information, that is false route reply to node 1 so as to pretend itself to be the actual destination and receives all the traffic further to the malicious node. For implementing sinkhole attack in NetSim, we have to add a file called malicious.c file to the DSR project, which is having these three functions mainly. So first function is DSR malicious node function, which is to identify whether this node is malicious or not. Then second function is malicious route add to cage, which is to add a fake route in the network to establish connection from the source. Now third one is malicious process route option, which is to drop all the received packet from the source instead forwarding it to the destination. Now for overcoming this sinkhole attack, we have an intrusion detection system that we'll see later. First we go to the software and see how we can implement sinkhole attack to programming in C language in Microsoft Visual Studio environment. So for implementing sinkhole attack, we already have the source code for sinkhole attack. So we can directly open the NetSim solution file for sinkhole attack. So DSR protocol is open here, and we can see malicious.c file is added, and we have opened the malicious.c file here. This is the code for malicious node. So first we have defined the malicious node, which is node 2. Node 2 is the malicious node, and we have three functions. First, malicious node, defining the malicious node, process root add to cache, adding the fake root, and malicious process source root option to drop the packets. So we have codes defined here. Now again we have to rebuild it, and after rebuilding we will get the DLL file for this in the DLL folder, libdsr.dll. So we have to copy this libdsr.dll and paste here in the bin folder of NetSim. So here we are having the libdsr.dll, which we have pasted here for hello world. So now we can replace this DLL to our sinkhole attack. Now this is our dsr.dll for sinkhole attack, and this is our original DLL, which is still there. So now if we implement sinkhole attack, that should use our edited DLL. For this, we have to open the scenario, which we have already created for a sinkhole attack. Configuration.xml file is for the scenario of sinkhole attack. So here we have defined 6 nodes, and we are sending a CBI application from 1 to 6. You can see DSR protocol is by default selected for all the nodes. You just have to check whether it is selected, because we have to use the DSR protocol only. Now we run our simulation. So it will ask you that detected a change in libdsr.dll. So you have to press any key and will simulate further. Now matrices are common, as we have seen in the normal scenario of MANET, DSR, UDP, IEEE, application matrix. So we'll see application matrix first. So in application matrix, we have added an application of CBR from 1 to 6. So in 1 is our source and 6 is our destination. So packet transmitted is 4019 and packet received here is 0, and our throughput is also 0. This is obvious because we are implementing a sinkhole attack is here, and this is not a normal scenario of MANET. So in sinkhole attack, as we know, source sends all the packet to the malicious node rather sending it to the actual destination node. So here it has done the same. It has not sent any packet to the actual destination. So our packet received and throughput is 0. So our actual destination is not having any packet, and the malicious node is having all the received packets. So we can see it through animation. So in the actual normal scenario, these devices help in communication between 1 to 6. But here in the sinkhole attack scenario, node 2 has been defined as malicious node, where when we send the packets from 1 to 6, it should send all the packet to node 2 rather sending it to the node 6. And node 2 also doesn't forward any packet to any node. So let's see whether it is doing the same. So after root request, root reply is being sent. Now malicious node to send the false information of the root that it is the actual destination, and you can see first application has been sent over this 1 to 2. Now second application is being sent, and it is not forwarding the packet further for the actual destination. the sinkhole attack is working. Now continuously it is sending packets to the malicious node. Now it is assumed that it is not it is the actual destination, and it is sending all the packet to malicious node. So we can say our sinkhole attack is working and malicious node is not forwarding any packet to the actual destination. This is how we can implement sinkhole attack in MANET. Now for overcoming this issue, we have an intrusion detection system that we can implement in NetSim. So let's go to our presentation and see how we can implement intrusion detection system or IDS. So intrusion detection system or IDS monitors the network for malicious activities, and once abnormal behavior is sensed, it takes preventive measures to recover from the attacks, and it keeps track of the network in future also to avoid such incidents. So IDS in NetSim has two major functionalities. First is watchdog and second is path rater. So here in Watchdog, a watchdog timer is added to each node in the network. This timer starts when a packet is sent in the network, and once the packet is forwarded to the next hop within the watchdog timer duration, and if the next hop is malicious, then it do not forward the packet further. Here, a counter is reached A counter is used to keep track of number of time watchdog timer expires, and once the counter reaches the failure threshold, the current node marks its next hop as malicious and send it for further blacklisting. And path rater adds malicious node to blacklist and validates routes by verifying route reply. It also discards route reply if blacklisted nodes are present in it. Now for implementing IDS in NetSim, we have to add two major functions in DSR project, watchdog.c and pathrater.c, where watchdog.c has two functions, add watchdog timer and watchdog timer executes. As their name suggests, first function is to add a watchdog timer to each node in the network, and second one is to check if the packet is sent before timer expiry, and also check if failure threshold is reached. Then second, pathrater.c has also two functions, which also their name suggests, add to blacklist, which add malicious node to blacklist, and verify route reply. It checks if the IP address in the route reply contains the IP of any blacklisted node. Now, as I don't have the codes for IDS currently, I'll show you this small video to show you how we can implement the IDS. So we have seen here that a watchdog timer is added to this source node, and as it sends the packet to all the nodes, this node 2 replies the fastest. So it assumes that it is the destination node. So it sends the packet to malicious node. But as there is a watchdog timer is there, so when it reaches the failure threshold, it sees that this is doesn't forwarding the packet to the other nodes and our actual destination. It defined it as a malicious node. Then it sends the root request to the node 3, and node 3 further transfer the packet to node 4 and node 5. So when actual destination sends the root reply, node 1 starts sending the packet to the actual destination and defined it as the malicious node and blacklisted from the network. So this is how intrusion detection system works. Now we have seen the presentation of Internetworks and MANET in our first part of the presentation. Now we'll have a 15-minute break. After the break, we'll have session on wireless sensor network and IoT. So please be there after 15 minutes. We'll have the presentation further. Thank you. We'll meet after 15 seconds, 15 minutes, and continue our presentation on wireless sensor network and IoT. Welcome back all of you after this short break. Now we will continue our presentation on wireless sensor network, is WSN. So WSN or wireless sensor network is based on IEEE 802.15.4 standard, which is LRWPAN, low data rate wireless personal area network, which is widely used because it has sensing capabilities that is position independent, which means it can be deployed where humans can't reach due to non-living or toxic conditions for humans. Sensors used are of very low cost and can be randomly placed in the sensor coverage area. So coverage range here in WSN is of 10 meter approximately with a transfer rate of 250 kbps, and it uses the CSMA-CA algorithm for collision avoidance. Then frequency range, it has 860 to 915 megahertz. Now these are some application of wireless sensor network where it can be used. So in first, in the healthcare domain, it is used for monitoring the body parameter of a person either through wearable devices or implantable devices inside the body. Then area monitoring, it can be used in a region where intrusion monitoring is required, like for detecting intrusion of enemies on border areas. It can also be used for battlefield surveillance in warfare scenario to monitor the situation and send proper support to the soldiers on time. For forest fire detection and other environmental monitoring, also it can be used. And various other applications are there in different areas like smart cities, smart retail, smart agriculture, smart industries, then smart animal farming, smart retail, different other applications are there for wireless sensor network. Now devices in WSN. Devices in WSN are of mainly two types. One is FFD, another is RFD. FFD is full functional device, and as its name suggests, it's having the full functionality, like it senses the agent, it routes the packet, it initializes the network and act as a PAN coordinator. It can also communicate with another RFD or FFD. Then second one is RFD, that is reduced functional device. So as its also name suggests, it can also only sense the agent and communicate with FFD only. So these two types of devices we have in WSN. So first device we used in WSN is sync node. Sync node is the principal controller in WSN, and only one sync node is used to receive data from sensors via a single agent used in the network. It can work on beacon mode or without beacon mode. When it uses beacon mode, it uses slotted CSMA-C algorithm for transmitting packets. Otherwise, it uses unslotted CSMA-C. Now, agents. Sensor receive the data from agents, and when it comes in the same sensitivity range, agent can have any sensing data like temperature, air, pressure, heat, etc. Agent mobility can be modeled by random walk and random waypoint, and its velocity can also be configured. Now sensors, WSN has the spatially distributed sensors to monitor physical or environmental conditions like temperature, sound, pressure, etc., which further pass their data to a main location through the network. Now this is the scenario of deployment of sensors and sync node in WSN, where sensor will sense the fire object and send the data to sync node. So fire object here can be our agent, which the sensor would sense the fire, its other parameter of heat it senses, and send the sensing data to sync node. Now scenario in WSN can be of two types. First is star topology, and second is peer-to-peer topology. So in star topology, PAN coordinator is centrally connected to other FFDs and RFDs in the network, and peer-to-peer topology, PAN coordinator is connected to other FFDs and RFDs in the network in peer-to-peer manner, as you can see in the figure also. So this is just to show you how we can connect our devices in two different manners in the same network. Now power model metrics. In wireless sensor network, power of the devices is a very vital parameter that has to be taken care of, because as much power remain in them, they can be active in the network. In the properties of the sensors, there is a power property where we can configure various parameters related to power, like power source. Either it can be battery operated or mainline. If it is battery operated, energy harvesting can be enabled to save energy, and some other parameters like recharging current, initial energy, transmitting current, etc. can be configured to get the most appropriate battery power. After simulation, it generates power model metrics where it logs the value of energy consumption by the devices, like transmission energy consumed, receiving energy, idle energy, and total energy consumed by the devices. So this is how we can configure our power parameter to get the most appropriate power to our devices for remaining power. And this is the generated output in power model metrics, that is the consumption of power by the devices. Now before moving on to the cluster head, let us design and simulate a wireless sensor network scenario to see how it will work. So for designing WSN, we have to go for simulation, and in new, we have to select wireless sensor network. As you select wireless sensor network, a window will pop up that is grid setting and sensor placement. So sensor grid setting, we have to give this side length. Side length should be an integral multiple of 50 between 50 to 1000. So we can give the side length 50, 100, 150, 200 in the multiple of 50 up to 1000. Then we have sensor placement strategy. With sensor placement strategy, we can define how we can place our sensors in the environment. So first is automatic placement, and second is via click and drop. So if you select via click and drop, you can directly drag and drop the devices from the menu bar, and you can design your network. And if you want to have the automatic placement, it can also be of two types. One is uniform placement, another is random placement. So you have to select the number of sensors you require in your environment. So that can be of a square number, that is 1, 4, 9, 16, 64 and onwards. Okay, so if you select number of sensors 16 and select random placement, so it will place the 16 sensors randomly in the environment. And if you select the uniform placement, it will select 16 sensors and place uniformly in the environment. So let's go with the default values having side length 50, automatic placement as uniform placement, number of sensors 16, and click OK. You can see we have got 16 sensors here placed uniformly in the environment. We just have to drop down this sync node and an agent in the network. Now we can see the properties of the devices. So let's say we have the properties of sensors. So in the sensors, we have global properties like other devices. Here we can define the mobility model also for the sensors because these are the wireless devices. So mobility model is there. So three types of mobility model is there: random walk, random waypoint, and group mobility. Application layer is defined outside. Transport layer is there. In transport layer, UDP is by default selected. In network layer, routing protocol DSR is selected. AODV, ZRP, and OLSR can be changed according to our requirement. Then interface ZigBee, we have different layer parameters. Having network layer, uh, we can change IP address and subnet mask. In data link layer, we can enable acknowledgement request, maximum CSMA, DO, and different other parameters. And all the parameters can be can have the information through this information tab. If you click on information tab, I have already shown you that we can see the different parameters of the layers provided here. In physical layer, we have other parameters. Then we have power parameter that I've shown you. We can set it for mainline or we can set it for battery operated. Then we can have the sensor parameters, sensor range and sensing interval. Okay, this is the range for sensor and this is sensing interval in which how much time it will sense the agents. This is how we can define the sensor. Now agent can be modeled, its mobility model can be defined because it has a global property as common and it has only the mobility model. Random walk and random waypoint. Then we can define the sync node. So global property is common, transport layer is there, network layer, same DSR protocol, interface ZigBee, we have same network layer, data link layer parameter. In data link layer and sync node, we can define the beacon mode. So if we enable the beacon mode, we have some other parameters that we can change to get our result: super frame order and beacon order. So by varying these two parameters, we can vary our result. Different result we get by changing these two parameters. So currently I'm going with the default by disabling the beacon mode, and the physical layer has same sensors. Then power parameter, it is by default connected to mainline. As sync node has to be connected every time to the network, so it is by default mainline. Now accept. Now before moving on to the simulation, we have to change something into the bin folder because we have modified the DSR DLL for the sinkhole attack. So now we have to retrieve our original DLL just to get the normal result. So we delete our sinkhole attack DLL and retrieve our original DLL by just again renaming it to libdsr.dll. Now we work on the original DLL. And we can run now. So we got performance metrics, first network metrics, and again some common matrices are there for every network. UDP DSR, where we get the 802.15.4 matrix, which is for wireless sensor network. So here we got the device information having packet transmitted, received, CCA time, successful CCA. And if we enable the beacon mode, we'll get the beacon transmitted information, beacon received, beacon forwarded, okay, beacon time, cap time, all this information of the CCA and beacon we got here in IEEE 802.15.4. Then we have sensor metrics. We got the sensor positioning here for each and every sensors, and also we have the agent ID. Okay. For each and every sensor we have the information. Then we have power model metrics, where we can see the energy consumption of the devices during the communication of the nodes. So transmission energy consumed, receiving energy consumed, idle energy, sleep energy, and total energy consumed is there for each and every node. Now we can see also the packet animation. Sensor will sense the agent and send the information to sync node here. Also, you can get information here in the log files running here along with the animation. So here we can see in a normal scenario WSN in the animation that sensors are sensing the agent and sending the data to sync node in a broadcasting manner. Every sensor is sending the packet in broadcasting manner to each and every node and to the sync node also. So energy consumption can be more here as every device has to be active to receive packets from each node. For this, we select some nodes from each cluster and make cluster heads in the network. Now every sensor sends the data first to cluster head and cluster head further send the data to sync node. So let's stop this animation and go for our presentation. So here in this screenshot we can see we are having 64 sensors having each cluster of 16, 4 cluster we have, and we have made cluster head to any of the node, any of the sensor. And now if you make the cluster head, so all other devices which are sending the data to sync node, it doesn't forward the data directly to the sync node. They first send the data to cluster head, and cluster head further send the data to sync node. So each and every node has doesn't require to active each and every time in the network. Whenever it sends the packet, it will get activated and send the packet to cluster head, and cluster head further send the packet to sync node. Now, for saving the energy of the cluster heads, we can implement a protocol called LEACH, that is low energy adaptive clustering hierarchy. It is a cross-layer protocol where cluster heads keep on changing according to the energy remaining in them. So we have made the cluster heads in the clusters. Now cluster head also keep on changing according to the energy remaining in them, because these are the wireless devices operating on battery, so they can have the energy. They lost energy during the communication. So as soon as the energy expires to the clusters, cluster heads keep on changing when we implement the LEACH protocol. So for implementing LEACH, we can add leach.c file to the DSR protocol, which consists of these four major functionalities. First is check destination, that is to check whether the device ID is same as destination ID, and then get next hop function is to add forward, used to forward the packet from the current cluster head to the next cluster head. Then assign cluster head is used to dynamically assign cluster head based on the sensor's remaining energy. Then fourth one is identify cluster. This function is used to identify the cluster of the sensors. Now before moving on to the IoT, let's implement LEACH protocol in WSN through programming and see how the LEACH will work in the WSN. So for implementing LEACH, we already have the codes for LEACH protocol. So we directly open the netsim.solution file for LEACH. Where we have to added two protocols, DSR and ZigBee. So in DSR, we have added leach.c file. And we have opened the leach.c file here. So here we have defined 4 clusters. Size of cluster is 16. So we have to use 64 sensors here. We have defined the clusters. And 4 functions we have: check destination, get next hop, then we have assign cluster head and identify cluster. So 4 functions we have and the codes accordingly. So we have to build these 2 files, DSR and the ZigBee. So after rebuilding, you will get the file in the DLL folder, libzigbee and libdsr.dll. These 2 files we have. So we have to copy these 2 files and paste again into the bin folder of NetSim. So any protocol you edit, you have to just paste the DLL, edited DLL here in the bin folder. So because in the bin folder only the NetSim GUI accesses the protocol. So here we are having the original libdsr.dll. So we can rename again to retrieve our original DLL to make it so this is the libdsr original. Now again we have to rename the libzigbee DLL also. So we rename it to libzigbee original.dll. Okay. Now we can paste our edited DLL and see libzigbee.dll is there along with original and libdsr.dll here along with the original DLL. So now we can implement LEACH. For this, we have to open our LEACH scenario. So go to open. You can open any network, existing network. So this open and network. You can also open the matrix file from there. So we have already the configuration.xml file for LEACH. Just open. So we have 64 sensors that we have defined in the program also. So we have configured the 16 sensors. We have made the clusters, 4 clusters we made of each cluster of 16 sensors. We have one sync node. We are using 3 agents. Okay. So we have defined the DL file. So we can run our simulation. So as we run, we'll see detected a change in libdsr.dll, again change in libzigbee.dll. So when you press any key, it will run simulation further. So the matrices are common here, as in the normal scenario of WSN. Here, LEACH matrix is defined here. Okay, along with the DSR, IEEE, and sensor matrix, power model matrix. LEACH is there, data sent on network layer, physical layer, data received on network layer, physical layer, and lifetime of the devices. This we can see in the LEACH matrix. Now, in the animation, we can see if it is in broadcasting manner or the data is sent through the cluster heads. So we run our simulation animation. We can see the sensors are sending the data through the cluster heads only and not in a broadcasting manner. What each protocol is working. Okay. So this is how we can implement the LEACH protocol. Now we go to the IoT part in presentation and see how IoT can be implemented in NetSim. So IoT can be understood from this very popular picture of IoT concept, where this picture itself tells us about the concept of IoT, that everything in this world, either it can be living organism or any object, can be connected in a network and they can communicate among them and share the information. You can see in the picture, everything, either it is living organism or an object, is connected to the network by using some devices. So this is the concept of IoT, and it is a very current topic of research in today's scenario. It is being used in many of the areas. So this is the application domain where it is being used. It can be used in healthcare, smart homes, smart agriculture, smart logistic, smart energy, and city management. So various other application it has. It is being used these days. Now, how we can implement IoT in NetSim? So IoT technology can be implemented here in NetSim, where we have modified WSN, where sync node is replaced by low pan gateway. So we have the same sensors in uh, apart from the sync node, we have replaced it from the low pan gateway, which receives the data from sensor and send further to other network in host server, where our data has to be stored. In the screenshot, we can see various devices are used to receive data in low-pan gateway, which further store it in the other host. So apart from sensor and low-pan gateway, we have to use internetwork devices like routers, switches, access point, and host. Data link and physical layer are configured as per IEEE 802.15.4. Network layer can run both on IPv4 and IPv6 protocols. Its routing is done via AODV, OLSR, and ZRP. Then C source codes are also available. You can see in the screenshot the standard version for modification. Like other protocol we have edited, we can edit the protocols in IoT also. So this is a low PAN gateway, which stands for Low Power Wireless Personal Area Network. It works on IPv6 protocol. And main difference between low PAN gateway and sync node is low PAN gateway having the WAN interface, where other network can also be connected through low PAN gateway. So now we go to NetSim and see how we can design and implement an IoT scenario. For this, again we have to go for NetSim simulation, new, and we have to select Internet of Things. Again, this window will pop up. So I've already shown you the detailed information. We just go with the default, having grid length and side length, and automatic placement, number of 16 sensors, 16. So click OK. You will get 16 sensors placed here in the environment. Now you have to place only the low PAN gateway. Now through this low PAN gateway, we can connect some other device so that sensing data captured from the sensors and sent over the low PAN gateway further can be restored, stored from to other location. Either it can be wired or wireless node. So we are having the Internetwork devices available here. So you can connect a router here. Further, you can add a switch. And connect a wired node. And if you want to have the wireless node, you can connect an access point, and a wireless node can be connected to the access point. Now we can connect these devices. So through wire link, now for the wireless node, you have to select the wireless link. Now the sensing data or application can be captured from the low PAN gateway, and low PAN gateway further transfer data to router, and router further distribute data to this wired node A to switch, or wireless node A B to this access point. Okay. So according to the application we set to which source to destination we have to send the data. So sensor properties we already know, and all the Internetworks properties also we know. We have seen in the Internetworks part. So we only see the property of low PAN gateway, where global properties are common. Application layer is defined outside. Transport layer we have UDP. In network layer we are using the AODV protocol here. And interface ZigBee, we are having the network layer parameters having IPv6, IP address. Okay, then data link layer we can set the acknowledgement request. Like sync node, we can enable or disable the beacon mode. Then in physical layer, you can define the same parameter as in WSN, and power is also mainline by default. Now we can set the application. Just right click on the properties. So a special kind of sensor application is there, sensor app for the sensors. So we can send the sensor app over different devices. Let's say from node 6, sensor 6, we are sending the data to the low PAN gateway, and further send the data to node 20. So 6 to 20 we are sending. So we select 6 to 20. having packet size and arrival time as same. And again, let's say we are sending some sensing data from 7 to 22 to this access point. 7 to, we have to add one application, application 2 from 7 to 22. Now we can see two lines sending sensor application from 6 to 20 and 7 to 22. Now we can run our simulation. So before running, we have to again edit these DLL files because we are using some ZigBee protocol in wireless. We have to edit ZigBee original because this is edited for LEACH protocol, and we have to retrieve our original DLL. If DSR also can be edited, but it is not using there. We are using AODV protocol. Now we are using our original DLLs and run our simulation. So again, we'll get the performance metrics having some common matrices, and in place of DSR, we are having AODV metrics because we are using AODV protocol. But it is also having the route request and route reply informations, and packet received, dropped, transmitted, all the informations. And we'll have 802.11 metrics of RTS, CTS because we are using the wireless nodes here. And we have 802.15.4 metrics. Same as in wireless sensor network. And power model metrics also for the energy consumption, same as in wireless sensor network. Then application metrics we have added two applications from 6 to 20 and 7 to 22. So we have seen we are in throughput. You can see packet animation from here. Sensors are sending the data to low-pan gateway, and low-pan gateway will further transfer data to these devices. We have defined wired node and wireless node. Okay. So I've shown you today how we can implement different technologies in NetSim, like Internetworks, mobile ad-hoc network, wireless sensor network, and IoT, and some attack problems in MANET also, like Sinkhole attack and its intrusion detection system, how we can overcome this issue. Then we implement the LEACH protocol for the cluster heads. So their cluster head keep on changing according to the energy remaining in them. Then we have seen how we can implement IoT in NetSim. So furthermore, if you want to design some other network apart from these that I've shown you, so I've tried to cover most of the topics which are currently the research topics of today's scenario. So we have advanced wireless network, MANET, WiMAX, BGP, cellular network having GSM and CDMA, and wireless IoT, Zigbee network, cognitive radio network, and LTE advanced network. So various other networks are there which we can design and analyze. So apart from this simulation, we have some programming exercises where some sample programming is running here in backend. Let's say we are having the cryptography substitution we have chosen. So a sample programming is running. Two mode we have, sample mode and user mode. So when you choose the sample mode, so the default programming runs. So let's say we are using the encryption method, and let's say I write NetSim and key text of 4 and run. So having the plain text and key value, it will give you the cipher text. And when you choose decryption, it will run again, and from cipher text, it will give you the plain text again. So this is how you can run the sample programming running in the backend. And if you want to have the your code, the user code can be implemented through this user mode. So when you click, it will prompt you to ask the exe file of the code. So for the exe file, you can open this sample code in the interface source code. It will directly open in the Visual Studio. So this is the code for substitution method of encryption. And if you want to change anything and create your own program, you can change here and save it in exe extension, because the user requires the exe extension to be used. Exe file it requires. So you can change anything into program and save it in exe extension. So either it can run through sample mode or user mode. Okay. And some concept algorithms are there for study purpose. Pseudocode, flowchart, everything is there for study purpose. Then in help we have user manual, where you can get the introduction of NetSim, getting started, how to install if you purchase this, how to install this, how to use it, simulation different networks are there. So it's a detailed manual of using this software. Then we have source code help for the developers. They can get this manual. So it's a 2000-page manual for programming. For development of different protocols, you can use this source code help manual. So it is available in the standard version. So NetSim has two versions. One is academic and one is research. That is standard version. So in academic version, you will have the GUI facility. So all this design you are having, you can design and analyze. But that programming portion, this Visual Studio environment, you can't create the DLL file and link it with NetSim to edit anything. So in the standard version, we have the provision of giving the source code so that you can edit any protocol and create your own protocol. So for this, user source code help is there, and experimental manual is there, which is there in the academic version also. Around 22 experiments we are already we have created. So if you click on any of the experiment, you can get the procedure how to use. The theoretical portion is also there. Its parameter are also defined by default parameters. You can use it and you can run accordingly. You will get the output. So you can study one by one the experiments. Step by step manual is there. You can do it yourself. You have the manual and the software. This is my today's presentation. I've done with my presentation. So concluding today's presentation, we have seen Internetworks, MANET, WSN, and IOT, covering most of the research topics we have currently in today's scenario. Now, if you have any query, you can ask me by writing your question in the question box. Or further, if you have any query, you can send your information to this email ID, and you can call me also on this number. We have a YouTube channel where different videos are provided. Useful videos are there, you can see. And some recorded webinar sessions are also there, previous webinar sessions. You can also go to our website for the product information. And if you have questions, you can ask me. There is a question. Let me know. CSMS CD and CSMS C is implemented. Yeah, it's implemented. I've already shown you that in WSN CSMS CA is used. So it is there. Any other queries? Demo version of the software is not provided, sir. Currently, company is not giving the demo version. If you require, you can go to our YouTube channel. There are a lot of videos are provided there to see the different technologies. You can go and have useful information there. If you require some more information, more clarification, you can contact us. Difference between WSN and IoT. I've already shown you in presentation and also the experiments also. In WSN we use the sync node, and in the IoT we use the low pan gateway, which is having the WAN interface, which can be further connected to some other devices like Internetwork devices I have connected in the IoT to save our information received from the sensors to some other devices like wired node or wireless node. That is the main difference between WSN and IoT. Both are depend upon the sensors, but loop and gateway further transfer the data to the other networks. So we have a combination of different networks in IoT. This is the main difference. Licensing of the software, it has a client server model. If you have the software, you will get the license dongle, USB dongle. The server will be connected with the dongle, and other clients will access the license. What are the securities in IoT? We have an encryption decryption model also. In the application layer, if you define the application running from one node to another, we have encryption. You can use the encryption, or if you want to edit some more securities in it, AODV source code will be provided in this standard mode. There you can add it if you want according to your requirement. For commercial details of the software, please mail us. If you require pricing and quotations, we'll send you on your mail. Please mail us. We'll send you the detail. Commercial detail can be provided on request, so please mail us, we'll send you. Versions are there, two versions, academic and standard. So both having the different pricing and licensing. Standard version is costly, obviously, and academic version is economical than this. Certificates we'll send on your mail. Within 1 week time, we'll send you the certificates. It will directly send you on email. If some people are attending in groups, please send us your details in Excel format that you are attending in group. So we'll send the certificates accordingly. And also the attendance sheet. We have sent you the format also for attending in groups. And you can send some pictures also if you have clicked when you are attending in groups. And if you are attending individually, no issues, we'll send you the certificate on your mail. Any other queries? If you have any query further, you can send me your queries on this email ID. You can call me on this number. So thank you for attending today's session. It was nice to have you on this session. Please send your feedback and suggestion if you have to improve us better. And we are having these sessions every Thursday in June. So if your other faculty and friends want to attend, the same session would be there on every Thursday. So please share that link you have with them. They can join the session by selecting the uh, appropriate date provided there. So thank you all for attending today's session.